Okay, so you guys are starting out with grade 12 physics, which one of the nice things about grade 12 physics is not actually entirely a new course. A lot of what we do in grade 12 physics actually, it actually builds on 11 physics. So this course is more of a continuation of grade 11 physics than a new course altogether. So that's why it's pretty much impossible to do well in grade 12 physics if you haven't taken grade 11 first, because so much of what we do in grade 11 feeds into grade 12. We just continue on those topics and build on them. Now, when you guys are in grade 11 physics, you guys are starting out, all that kind of stuff. One of the things that, of course, throws people off or scares people, we talked about this at the beginning of grade 11, is the whole math part. The whole math part sort of often, there's often a lot of fear involved for some people in terms of physics and math and that type of stuff. But hopefully what you guys we talk about this in grade 11, but hopefully you guys realized as you did more and more stuff in grade 11 physics, there's a big difference between just doing math and actually applying math. So we typically try and apply math rather than just trying to do pure math. And when you apply the math to actual situations and scenarios and stuff, that is often very different because the symbols mean stuff and the graphs actually connect to situations, all that kind of thing. So a lot of people actually like the math better because it's not just pure dry math, we're actually connecting it to situations. And in fact, it's often really, really hard to actually do physics when you can't connect it to those situations. So for example, last year, if you guys remember, we did the 4 modes. Let's see if you guys remember that. The first one was the physical conceptual mode. We had the numerical mode. We had the graphical mode. And then we had the symbolic mode. And of course, the symbolic one is the one that's often typically the formulas, and that's what most people think of when they think of physics, is all these formulas and equations. But as we're talking about in grade 11, there's the situation, there's the values that you can get from the situation, there's the graphs that then represent the situation, which eventually results in the formula or the symbolic representation. And unless you can connect to all 4, it actually can make things a little more difficult. And if you just focus on the formulas, you just focus on the pure dry math, it actually doesn't usually work very well. You want to be able to connect it to the actual graphs, numbers, and more importantly, connect it to that actual situation so you can actually see how things connect and how one thing will affect something in an actual scenario. So we will build on grade 11 ideas and keep on building on grade 11 ideas, and we will continue to apply the math. You just got to be careful not to just think about just the formulas. Remember to try and connect them to situations and that type of stuff. But one of the things that kicks in then is you still need to have that basic math background. You still, in order to do this, you still need the actual basic skills in order to actually apply it. So you want to be able to have those basic skills. You don't really have to worry about how to do the math. It's more about, now you can worry more about connecting the math to the situation. That's why, like in grade 11 physics, there really isn't anything that is not grade 9 or 10 math, because we assume and know that you guys can do a lot of that math. Now we can focus more on how to actually apply it. So I didn't have to teach you guys trig or Pythagoras. You guys have done that before, but now I can show you what it actually was used for. Same thing with algebra and graphing and all that kind of stuff, and slopes. You guys have been calculating slopes for a couple of years. Now I actually was able to show you what they can often be used for. So this is the math thing that kicks in with grade 12 physics as well. So one of the things you want to start with in grade 12 physics before we actually get into like the actual physics type stuff, let's go back, let's practice some of the basic math skills again, so when it actually comes to applying them, it won't be as difficult. So here we have a basic math sheet. It's sort of like a physics math review sheet to illustrate some of the basic skills that, of course, you guys will apply. And the first thing we got going on here is some good old-fashioned triangles. And you guys know we did a lot of triangle stuff in grade 11 with vectors and that type of stuff. whether using trig or Pythagoras, that type of stuff. So let's just review some of the ideas, get that stuff going again, and then we can worry about applying it later on. Okay, so first one here, we're just going to solve for the unknown sides and the angles. They're all just right triangles. We like to work with right triangles so we can apply different types of math to them. So let's just start with that. So the first triangle here, we got a little triangle. We got the 27 degrees in here. That's a right angle right there, of course. So, of course, sum of all angles is going to be 180, so this would have to be 63 degrees. And I'm just going to keep on going with this triangle and then polish off. Now, the only thing I'm missing for that one is the one side. I'm missing this one side over here. There's a couple ways that you could do it. Doesn't make any difference. You've got the 12.6, you've got the 15.2, so you could easily use Pythagoras to solve for that side. Do the 15.2 squared, subtract the 12.6 squared, and then just root the difference, and you will have that missing side. Some people like to use trig. You could use the trig function with the 27 or the 63 to figure it out. It doesn't matter. But once you sort of plug that away and use whichever method you want, you should get around 8.5 for that side right there. Okay. Now, if we go to the second triangle, this is a right angle right here. We don't know either of the two angles, but we do have those two sides. We got the 0.86 and we got the 1.24. So here we got to start basically, we can start with some Pythagoras if you want to. You could do the 0.86 squared, the 1.24 squared, add them together to get the hypotenuse. You could do that. You could also use trig as well once you got an angle. But using a squared b squared equals c squared would probably be the easiest way to find that side. So if you go through that, you should end up with around 1.51 for the missing side over there. And then once you get all the sides, the angles can really kick in. Now, it really doesn't matter which trig function you use to find the angles. It's not a bad idea to try and stick with initial values, like try and stick with the 0.86 and the 1.24. Because if you messed up on the 1.51, then your angles are going to be off. So I'd probably try and stick with the 0.86, the 1.24, which means if I'm solving for this angle right here, I would use my tan function, and it would be opposite over adjacent, so 1.24 divided by 0.86, and then I inverse tan that, and if I do that, I should get around 55 degrees. Now you could have solved for this angle first if you want to. It doesn't make any difference. And you could use tan to solve for that one if you wanted to. Or since you know you got the 90 degrees in the bottom left, that one's 55. There's no option. This would also have to be 35 degrees, so it also adds up to the 180. Okay, so triangle all solved. All right, if we go to the last triangle, got the 28 down here. We've got the right angle, which means this missing one over here has to be 62 degrees. I only have the one side, so I'm not kicking into Pythagoras or anything like that. I've got the 152 up top. I've got that. So if I was going to solve this for my sides, I got to use some trig here. I got the 62 degrees. I've got the 28 to choose from. I'd probably try and stick with the 28 because that's an initial given value, so I know it's right. Again, if I messed up the 62, then my sides are going to be wrong. So I'll try and stick with the 28. I could solve for this side right here first. I'll use my tan function. So the tan of 28 would equal to 152 over my missing value. And if I would punch that out, this should be around 286. And then once I've got that, I got the two sides, then I can just use Pythagoras to find the hypotenuse. Or, I mean, you could use trig. You could use the 28 and the 152 and the sine function to find the hypotenuse. It doesn't really matter. There's lots of different ways you can do it. Either way, you should get around 324 for that side. Okay, so a little bit of trig, a little Pythagoras. Good to know these skills because you guys know where you're going to be using them for, especially things like vectors and that type of stuff. Okay, so another basic skill, of course, is basic algebra. So let's look at that a little bit as well. And of course, algebra is something you guys work on for a number of years as well. And of course, especially grade 12, the formulas, the expressions will get a little bit more elaborate, not necessarily more difficult, but a little more rearranging typically than grade 11. But again, nothing really past grade 9, 10 math skills, just a little bit different, trying to apply it rather than learn it. Okay, so let's just practice some basic algebra here. All right, so let's go to the first one, basic algebraic expression. I'm just going to move some things around and solve for x. Just good old-fashioned algebra. Now, probably the first thing I'd want to take care of is getting rid of that negative 11. So if I multiply by negative 11 both sides, I'd end up with 9x minus 15. Negative 11 times negative 6, of course, would be 66. Then you'd probably want to add 15 to both sides. So you got the 66 plus the 15 is going to take you to 81. And then, of course, divide by 9 on both sides, where you can see, of course, x would have to be equal to 9 in order to get that 81. So x is equal to 9. Good old algebra. Okay, similar for number 2, I probably want to start by multiplying by 6 on both sides. So this would be negative 10x plus 14. I've got the 6 times 24, which of course is 144. And then I would want to subtract 14 from both sides and then divide by negative 10. And when I'm all done, I'm going to get a value of x equal to minus 13. Now, you can do in-between steps if you want to. Some people can do this mentally, some people can't. I don't actually mind if you guys, go for it mentally and get it wrong and adjust later on, because it's just good exercise for the brain. Okay, so for number 3, got to get rid of those stupid brackets over there. I'm just going to multiply this out. So we got minus 291 equals 3x plus a negative 30x. So, you could have just gone right to the negative if you wanted to. So, minus 30x and then take away 48. You want to combine like terms, of course. So, you'd have the minus 291. You get 3x, take away 30x. So, minus 27x, take away 48. And then you'd want to add 48 to both sides, divide by negative 27. And once you get that done, and hopefully you're going to end up with x is equal to 9. Okay, and next, number 4. First thing I'd want to do is subtract 4 from both sides. That would leave me with 7 is equal to x over minus 2. This one's pretty easy. Multiply by negative 2 on both sides, and of course x is equal to negative 14. Alright, so next one, again, is more of a combine like terms type thing. So I would add 118 to both sides. And then you could subtract 17x from both sides if you want to. Again, there's different ways you can do this, different orders you can do it. It doesn't really make that much difference. Combine things out, and hopefully you guys will end up with x is equal to negative 51. Again, do your work, do your steps, how you see, do the order you want to do. As long as you don't break like order of operations, you're fine. And hopefully you'll get to that x equal negative 51. Last one here, add 23 to both sides, no big deal. So we'll do that. And of course, 27 plus 23, of course, is 50, is equal to 5x. And of course, then x is equal to 10. That's pretty straightforward. Now, again, none of this is actually past grade 9 math. It's just getting back into the flow, getting back into the habits and that type of stuff. All right, now, next. This one's a little bit more grade 11 physics-ish. Technically, nothing really past grade 9 math here, just a little bit of an application type thing, and finding the slopes on graphs. Now, we've got m values, got m values, so we're going to map things out and see what we got here. So, I'm going to make this my n side, I'm going to make this my m side. And if you're from grade 11, we want graphs to be nice and make sense and distribute things nicely and lots of room, that type of stuff. So if I look at my n values, I'm going all the way up to 7.7, which is kind of an inconvenient number, but it's really close to 8, which actually will work out probably pretty nicely when we sort of map out the bottom axis. So let's see if I can fit that across. If I got to go up to 8 with this thing, it will work out pretty nicely. I don't think I can do, well, it might actually work. If we try like 1, 2, 3, 4, going up 2 spots each time. Yeah, actually that fit pretty nicely. And then on my m-axis, I've got a 38, so 40 would be a good nice number to go to. And I can probably go up by 1 each time, maybe even 2 at a time. Let's just see how many blocks we have and see if that's going to work out. Seems like it might be a little much. Let's just try going up by maybe 5 or 10 each time, or maybe 2, and let's see if we can get this to all fit. If I count my boxes, though, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. It looks around 18 boxes, so going up by 2s won't quite fit, so we'll have to go up by a different value. Let's just try going up by 10 every 4 boxes, because I got to go up to 40. So let's say that's 10, we'll say it's 20, 30, and 40, and that actually fit pretty good. Okay, so let's plot points, and we'll try and make our points nice and big and healthy. Remember that from grade 11. So if I go, my first point is 0.5 and 1, so I'll go to 0.5, 1, so that's actually way down here somewhere. And then I've got 1.2 and 8, so 1.2 and 8, so somewhere around there. 1.6, 14, so I got 1.6 and 14 to be around there. And remember from grade 11, points nice and big and healthy shows a little bit of give, a little bit of error, especially if they are experimental points. Our next one's 2.4, 22, so we got 2.4. And 22 would be right around there. And then we've got 29, 3.2, or sorry, 3.2, 29. So we've got 3.2 and 29 would probably be right around there. No, don't want that. 3.2, 29. Okay, somewhere around there. 5.3, 36. So 5.3. 36, looks like we got the curvature kicking in, and 7.7, 38, so 7.7, 38 would be out here somewhere, maybe something like this. All right. Okay, so we got our points. Now we want to draw our curve or line of best fit. Definitely is a curve. I don't know if this starts at the origin or not, so won't worry about that too much, but try and draw a nice little curve here. Remember, you want your curves to be smooth. It's not really about hitting the points. It's more about symmetry and good generalization and good averaging out overall. So let's see if I can do a relatively good curve of best fit here. Maybe something like that. It didn't look very good. Let's try something else. Oh, I lost my last point there. 7.738. Right around, oops. On there. Alright, so let's try again. Alright, that's not too good either. Let's try one more time. I'll try and go backwards actually. That's not too bad. Well, we'll try and work with that. Kind of working on writing on a computer here, it's a little bit trickier sometimes. Alright, so we'll try this a little bit. Alright, so we want the slope at n equals 2 and 5. And this is where, if you guys remember, this is where tangents kick in. So the first one here, I'm trying to find the slope at n equals 2, which would be right around here on my graph. Not the smoothest graph, but we'll see if we can get a little tangent going on. So remember, we're going to try and draw a line that skims the graph at that location as best we can. And again, remember, everybody draws their curves and lines a little bit differently, so you can get slightly different values, but that might be approximate tangent at n equals 2. So then I need a couple points in order for this to work. So if I get my points, if I look at the coordinate, it actually looks like around 2 and 17.5, give or take a little bit. So let's say that's 2, 17.5. And I'm going to use my little intercept here, actually, because that makes things easy. And this looks around 0 and maybe 2. So it looks like 0 and 2 for an intercept right there. So I've got my two coordinates. I got 0, 2, and I've got 2, 17.5. And this is where you can use your delta y over delta x in order to figure out your possible slope. And for me, my delta y, we're looking around 15.5. My delta x is around 2. So we're probably looking around 8 or so for a slope at that location. Again, people enjoy hopefully your curves better drawn than mine, because I had to draw mine on a computer screen, which is kind of horrible. Hopefully yours is a little bit better, but hopefully you get a tangent around 8 or 9 or 10, somewhere around there, give or take a little bit. Hopefully somewhere around there. Okay, so let's do it now at n equals 5. So if I go to n equals 5, we've got n equals 5, so right around here. So I'm going to draw a tangent to that location. So something like, angle it up a little more. Let's try again. Go that way. It's not too bad. Maybe something like that. Okay, so remember, I'm looking for symmetry on either side, there and there, seeing as the curvature on both sides is about the same. Okay, so let's grab a couple points from here. I'm going to use this coordinate right here, actually, as well as I can use intercepts if I wanted to. It doesn't really make too much of a difference, but this one will approximate, it looks like around 5 and 32.5, so it looks like a 5 and 32.5 is my second point. And here I'm going to use this intercept. It's easy. It looks like 0.20, something like this. So again, people are going to draw it differently. You're going to have different points, but hopefully your overall tangent slopes are going to end up being about the same. So if I do my delta y over delta x again, which I guess is technically delta m over delta n. My change in y, or my vertical, I've got around 17.5, and my change in x was around 5. And we'll divide that out. And looking around, for me, it looks like around, well, just over 3 or so. Okay, somewhere around there. So it looks like around 3. So hopefully you got somewhere around there. Again, 3, 4, 2, somewhere around there, give or take. Hopefully you didn't get like 28 or negative 29 or negative 3 or something like that, because then you probably just, reverse something. But hopefully somewhere around there. Okay, so again, this is one of those basic skills you guys used in grade 11. Basic graphing, drawing a tangent, and then basic slope, which is a grade 9 type thing. So again, nothing really new. Just doing this to warm up your good old grade 11 math skills from physics, because of course we will be applying them again this year.